Okay, in this video we're going to look at esters, which are quite an important type of organic molecule in flavourings and in smells, fragrances. Now, esters are formed between two organic molecules that you will be familiar with alcohols and carboxylic acids, in a process called esterification. Okay, esterification. And it's where we get an alcohol and we get a carboxylic acid, and we put those in acidified conditions. So we usually use something like sulfuric acid to provide protons, H+, to produce an ester and water as a byproduct. Plus water. Now you can see this happening just here. So this is a random carboxylic acid with an R group, which is an alkyl group, which they use the letter R for, because it could be any alkyl group at all. Then you get an alcohol, which has a different alkyl group, which they've done R- to show it's a different one to this one. And when combined with the acidified conditions, they react to form this ester. Now, this means that we can combine all sorts of different carboxylic acids with different alcohols to produce different esters. So you can see an example here where we use benzoic acid, which has a big benzene ring attached to it, with ethanol, acidified conditions, giving ethyl benzoate. So let's just pick apart the naming of that for a second. So the benzoic acid part becomes benzoate when it forms this particular structure. So if we just see where the benzoic acid bit is, okay, and that's the same part that you can see here. The O in the OH actually leaves to form the water. And the ethanol forms the ethyl group attached to the end, which you can see here. And actually the O in the ester is originally from the alcohol. So this is the part that comes in here. And so these combinations come together and form lots of different esters, and they always have these names where you'll have the alkyl part. Alkyl is from the alcohol, and this bit is from the carboxylic acid. And let's look at some varieties of what these can produce. So these are some familiar smells that you're probably used to. So things like apple smell, raspberries, tropical fruits, mint, peaches, the smell of pine. This is actually a rum smell there, so I guess you'd have that in certain flavoured like chocolates and stuff like that. Pear drops. All of these things, these smells, are made by the chemical called an ester. So if we combine these alkyl bits here with these ions on the left here, we can combine them to make esters. Now, remembering that this bit is from the alcohol. Okay, so originally that wouldn't have been, say, heptyl, that would have been heptanol. Let's just focus on one particular, let's just look at this particular substance. So that's made by heptyl propanoate. Heptyl, and then propanoate. And that would have been produced by the alcohol heptanol. So if I just move this over to the right a sec. Heptanol, heptan 1-ol, and propanoic acid. and that would have made heptyl propanoate plus water. So that's called esterification, that process, and that's how you can combine different alcohols, different carboxylic acids to make different esters. So these are the range that you can have. There's lots of different fragrances that you'd be familiar with: coconut, cinnamon, even the smell of roses. So these esters are all very important in the production of food additives and in fragrances. Now, if we look at properties of esters and compare them to alcohols and to carboxylic acids, you'll notice that the boiling point is a lot lower. Now this, you guessed it, is because of hydrogen bonding. If you look at the structure of an ester, let's just take a simple ester like this methanoate one here. So methyl methanoate. So that's the methyl part, and that's the methanoate part. We'll notice that there's no OH group anymore. No OH group. And therefore, they cannot hydrogen bond. So the lack of the OH group means that they can't hydrogen bond. They will still have dipole-dipole forces. And they will still have dispersion forces. So dipole-dipole and dispersion forces only. And for that reason, carboxylic acids have the highest, followed by alcohols, followed by your esters.